Hello everyone, I am Dr. Ganesh Gollavelli, Associate Professor of Chemistry from Aditya Engineering College, Sorampala. Today I am going to discuss about electrochemistry, and here is the learning outcome of the topic. At the end of this lecture, student will be able to learn basic knowledge about electrochemical cell and rechargeable battery. The battery is what we use in the cell phones. So here are the outlines. It contains electrochemical cell, electrolytic cell, and lithium ion battery. Here, the cartoon represents electrochemical cell, which can convert chemical energy into electrical energy. So based on that principle, we construct batteries. So here is an electrochemical cell, and examples for electrochemical cells are galvanic cell or Daniel cell. As we discussed earlier, electrochemical cell converts chemical energy into electrical energy. Typically, it contains two half cells. One is anodic half cell, another is cathodic half cell. In each half cell, we have a metal solution, and in which we just immerse a metal electrode. For example, we have taken 1 molar zinc sulfate solution. In this solution, we immerse a zinc metal rod as an electrode. Whereas in case of cathodic half cell, we have taken 1 molar copper sulfate solution. In 1 molar copper sulfate solution, we are going to just immerse a copper cathode metal rod. And these two electrodes has been connected externally, and these two solutions has been connected through salt bridge. So when you keep a metal rod in a metal ion solution, some potential would be generated here. So with respect to the electrolyte solution here, the zinc loses its electrons. So here the zinc loses electrons and the zinc converted into Zn2 peaks. And this process is known as oxidation. Simply at anode, oxidation takes place and zinc would possesses negative charge. Whereas at cathode, the copper acts as a cathode and it will gain the positive charge with respect to the copper sulfate solution. When you connect these two electrodes through the external circuit, what happened? The copper gains the electrons from the zinc. So here the copper takes the electrons from the zinc and it will undergo reduction. Such how the combination of oxidation and reduction, electrons would be transferred from anode to the cathode. As we know, the movement of electrons is known as electricity. Such how electrochemical cells would produce electrical energy from chemical reactions. So here, how to represent an electrochemical cell? How to write in a format? So first, when you're writing electrochemical cell, first you have to write anodic compartment at the left hand side. So cathodic compartment at the right hand side. First, you have to begin the anodic compartment with the electrode. What the electrode we have used here? Here the electrode is zinc. And what the state of the zinc? It is a solid in nature. So that we have to represent in the brackets. After that, you have to write a vertical line or a slash. The next component, the second component is zinc sulfate solution. 1 molar zinc sulfate solution. That you have to write it down. Zinc sulfate solution, whose concentration has to be written in a brackets. That is 1 molar. After writing anodic compartment, we have to write a salt bridge, because here the salt bridge connects another half cell. The salt bridge usually represented with 2 vertical lines. This is the third component here. After the salt bridge, we have to write electrolyte solution. This is the fourth component. Here, the electrolyte is 1 molar copper sulfate. The copper sulfate, whose concentration is 1 mole. slash, and the fifth component is electrode. What is the electrode here? Copper is an electrode. It is in solid state in nature. Such how we have to represent the electrochemical cell. So not just you can construct a cell with zinc or copper electrodes. You can choose any electrode based on their electrode potential values. We can just arrange many metals according to their electrode potentials from high voltage to low voltage. Okay, so the order of arrangement of electrodes according to their electrode potential from low to high with respect to standard hydrogen electrode is known as electrochemical series. See here, we have different electrodes: lithium, potassium, barium, calcium, sodium, magnesium, aluminum, zinc. And here these electrode potentials are -3, -2, -2.9, and so on. You will get these electrode potential values based on its reduction. If the lithium gain the electron and reduce into lithium, then its electrode potential is -3.05 volts. Such how zinc 2+ has taken 2 electrons that convert into zinc. So during this chemical reaction, it has been produced -0.76 volts. This voltage would be produced or calculated with respect to standard hydrogen electrode potential. So in order to construct a battery, these electrode potential values are very, very, very important. As you know, an electrochemical cell contains anode and cathode. Because of oxidation reduction, movement of electrons happen. The flow of electrons is known as electricity. So here you can see the elements whose electrode potential is negative or less than 0 would act as anodic materials. And electrodes whose potentials are greater than 0 with respect to hydrogen would act as cathodic materials. So in order to construct a battery, we need anode and cathode. So unless that, we cannot produce current. So that's why knowing about electrochemical series is very, very important in electrochemistry or battery industry. Wow. So another type of cell is known as electrolytic cell. Electrolytic cell is opposite to the galvanic cell. In a galvanic cell, a spontaneous reaction produces electricity. That's what we studied. But whereas in case of an electrochemical cell in which electrical energy brings about chemical reaction is termed as the electrolytic cell. Here we apply a DC current to the galvanic cell. See here, this is the galvanic cell. This we already discussed. So here we have zinc anode, copper cathode. The combination of these two electrodes would produce 1.1 voltage. So during the process, zinc loses the electrons, isn't it? So in a galvanic cell, zinc loses the electrons. So in this process, zinc gradually melts because zinc loses the electrons. Those electrons would be taken by the copper, and the Zn2+ would be come into the solution. So eventually the zinc rod would melt. After a certain time, there is no electrons available from the zinc. So the electrochemical reaction would be stopped. And this process is known as discharge process. This we usually observe in non-rechargeable batteries. But in electrolytic cell, what happened? When you connect this cell or this system to the DC current, when you supply a DC current whose voltage is greater than E cell, means if you can supply voltage of 2, 3, or 4, what happened? The reversible reaction would take place. Means here at copper, oxidation takes place. Means the copper loses the electrons, whereas zinc take the electrons back. So here zinc Zn2 plus in the solution would take the electrons and that will convert into zinc. Means again the zinc electrode would be regenerated, and this process is known as rechargeable process. It would happen in rechargeable batteries. Such a combination of discharge and charging would produce a rechargeable battery or a modern battery. Wow. So here is an example for modern battery that is known as lithium ion battery, and let us see how it works. Most of us know lithium ion batteries are very important in computers and mobile phones, or even in electric cars. So here lithium ion battery also a kind of galvanic cell and electrolytic cell. Well, as we know, an electrochemical cell contains anode and cathode and electrolyte. And anode and cathode would be connected to the external circuit. Let us see what is the anode here. Anode is made up of a graphite intercalated lithium. At anode, we have a G means graphite, and it has been intercalated with a lithium. Here, the red dots represents the graphite, and the green one represents the lithium. A lithium has been intercalated between the graphene layers. Well, here the graphite would be coated on top of the copper foil. Here you can see this is the copper foil. On top of the copper foil, we just coat a graphite materials to make the electrons flow easy. Yeah, wow. So here at a cathode, it is made up of lithium cobalt oxide that has been coated on top of aluminum, because aluminum would encourage the better conductivity just to flow the electrons between anode and cathode to anode. In between, we have a separator, something like a salt bridge, which can separate anodic material and cathodic materials. Mostly it is made up of polymer, lithium ion or lithium salts coated polymers that act as a electrolytes or a separator. While as like galvanic cell, these two electrodes, anode and cathode, would be connected to the external circuit. As you know, the principle of a galvanic cell, here the anode would undergo oxidation, means here the lithium would undergo oxidation. That will convert into Li plus and electron. See here, this is the lithium. When lithium undergo oxidation, it will produce electrons and will produce a lithium plus ions. And here these electrons would just travel through the external circuit and reach to the cathode. The electrons are reaching to the cathode. So here the Li plus ions would move from anode to the cathode, and again the lithium would take this electron, and that will convert into lithium GL. So if you come for the cell reaction at anode, lithium undergo oxidation, so that will produce Li plus and electron, Li plus and electron. And these electrons would be taken by lithium at a cathode, and it will convert into lithium cobalt oxide. This is a discharge process, means the anodic metal would be gradually depleted. There won't be any lithium further. Okay, so how you have to recharge the lithium ion battery? I mean, there is a charging process. When you plug the mobile phone, what will happen? The battery would be charged again, something like this. So here, this mechanism would exactly equivalent to the electrolytic cell. So when you give more voltage, what happens? A reverse reaction takes place. Means here at cathode, convert into anode when you just come to the DC current. So here lithium cobalt oxide would act as an anode. Anode means loss of electrons. Here lithium cobalt oxide means here the lithium lose the electrons. So those electrons would just travel back to the anode. And these electrons would be taken by Li+. Such how again the lithium would be restored at the anode. So here in an electrolytic cell, the anode would act as a cathode. So here the graphite lithium would take the electrons that will convert into lithium. Such how charging and discharging would happen. So once the phone has been charged, what we do? Just we discharge it. We disconnect the DC current. And again, we start using. When you're starting using, the lithium ion battery would act as a galvanic cell or electrochemical cell. The chemical energy would convert into electrical energy because of the oxidation and reduction. So once again, the mobile phone has been discharged completely. What we do? Again, we have to give a DC current. So again, the power would be recharged, restored. Such oxidation and reduction reactions would produce electrochemical energy into electric current. So here are the typical cartoons. We show example for lithium ion batteries. We mostly use in modern electric vehicles, so-called Tesla. Where see here, this is, so here this is an anode and this is a cathode. This is a separator. Here the lithium ions are moving in between these two. So lithium ion batteries are light in weight because we simply take now copper foil and aluminum foil. In between we have a polymer separator which is coated with lithium electrolyte. Well, so that's what about how to manufacture a modern battery and how does it works. So what is the advantage of lithium ion battery then compared with lead acid battery? Here you can see mostly we know most of the vehicles we run with lead acid battery. It's also rechargeable battery, but it occupies a lot of space. See, the vehicles run with lead acid battery would occupy a lot of space. And acid and lead, these two are harmful to the environment. But whereas the vehicles run by the lithium ion batteries are smart enough, it occupies less space and it is eco-friendly. Its weight is almost low. So that's why lithium ion batteries are highly advantageous than compared with lead acid batteries or other batteries so far which has been commercialized. So that's why it's very important to choose electrolyte materials to construct a battery. Well, so here is the summary of my talk. We discussed about a difference between electrochemical cell and electrolytic cells, and what is electrochemical series and how it would be helpful to design a battery. And we also discussed the working of lithium ion batteries in electric cars and mobile phones. So thank you very much.